Okay, Mom. We're going to learn something you probably don't remember. Pythagorean Theorem.
I can't even say that word.
Try it.
Pythagorean Theorem.
Okay, Pythagorean.
Pythagorean.
Pythagorean
Pythagorean
Theorem.
Theorem. Serum.
No, I almost named my daughter's middle name Pythagoras.
Did you really?
Yeah.
That's awful.
I'm just
Nicole.
kidding.
Oh
Okay,
my God.
okay, so this guy named Pythagoras supposedly
That
discovered.
is not true.
No, it's true. It's like a Greek
A
person.
Greek god.
Maybe.
Pythagoras?
Yeah, he discovered this
Sounds
theorem.
like a dinosaur, Nicole.
Oh my gosh. Okay.
Tyrannosaurus.
No, it's Pythagoras.
Pythagoras.
Okay, so this is what he discovered. And it only works for right triangles. Do you know what a right triangle is?
That.
Yes, but like this triangle is not right.
No, it doesn't look right.
Mom.
It doesn't look right.
Okay, but do you know what a right angle is?
That.
Okay, it's like...
A square. That looks like a loser sign.
I know, it's that corner.
That's a
It
loser.
has to have a 90-degree angle.
Okay.
90-degree angle. Loser sign.
Loser.
Okay, so in our triangle, this is what Pythagoras found out.
That's a real person?
Yes. Okay.
I don't know if I believe you.
No, this is true. But these numbers that I write here are not gonna be proportional. Like, it's not gonna be accurate with the triangle that I drew, okay?
Okay.
So let's pretend this side length is 4.
Okay.
And then like 4 inches.
Okay.
And let's pretend this is 5 inches.
Okay.
Pythagoras found out how to find this length. Do you know what that length is called in a triangle? The one across from the right angle?
The left angle.
It's called the hypotenuse.
No, it's not.
Yes, it
The
is.
hypotenuse? Oh my God. That's weird.
I
Is
know.
that the same? Did another guy invent that?
Maybe his middle name. I don't know. Okay, so this part of a triangle is called a leg.
Okay.
And this is another leg.
Okay.
And the opposite one of the right angle is always called the hypotenuse.
Hypotenuse leg.
Well,
This is one leg. That's another leg. That's the hypotenuse leg.
hypotenuse.
Okay.
Okay, so what he found out was if you take this number
Mm-hmm.
and you square it,
Oh my gosh.
so 4 squared, do you know what 4 times 4 is?
Mm-hmm. 16.
16.
Well, I was going to say it. You didn't tell me to say it.
Okay, and then square this side,
5 times 5.
which is
25.
right. If you add these two numbers together, okay, so 25 plus 16 is 41.
Mm-hmm.
So Pythagoras found out that if you square this and you square this, you get what this is squared.
Oh.
So whatever times itself is 41.
41 times 41?
No. So this side is equal to something times itself, just like we did with these. And then once you do that something times itself, you would get 41.
Well, something can't be times itself to get 41
it'll
because it's an odd number.
Well, it'll be a decimal number. I mean, this is an odd number, but this is not going to be a perfect number. Like 5 times 5 is 25.
So it's
6 times
20. Well, it'd be like 20.
Not 20. That's way too big.
Oh.
So like think of it like this.
2.
6 times 6 is 36.
Oh.
7 times 7 is 49.
So
So
6
this-
times 7 is 42.
Well, this is going to be a number in between 6 and 7.
Yeah, 6 times 6 is 36. So, yeah, it's got to go 6 point
Yes.
something.
So if you took your calculator and you typed in square root
Oh.
of 41,
Okay.
you would get,
Well, do you know it?
well, not in my head.
Oh, I thought you were like a human calculator.
Well, the answer that I would give for this is square root of 41.
Oh.
You can just say it like this, but this is hard for people to understand at the very beginning. So what I would tell you is to get your calculator. Let's take a quick calculator break. Okay, so I'm going to type in 41, and then I'm going to type square root of, and we get 6.403, and it goes on and on forever.
Okay.
So we could just round it to the nearest tenth, and we could say this is approximately 6.4.
I didn't even know that meant approximately. Those little little lines.
Yeah, you did.
Squiggle lines?
We've taught it. We've talked about it once.
That. Okay.
Okay, so this side length has to be around 6.4 inches. If this is 4 inches and that's 5 inches, that's what that has to be.
Okay.
Okay, and then just to let you know, if you wanted like a visual model, like 4 times 4 would make a box like this size, its area. Like a 4x4 box would look like that.
Yeah.
A 5x5 box would look like that.
Why are we doing this?
I just want to show you one thing. A 5x5 box would look like that. And if we took the area of both of these boxes and added them together, we would get exactly that box.
Oh my gosh.
Okay, that was a lot.
That's a lot.
We're going to backtrack just a little bit and practice some simple problems, and then we'll make a Pythagorean Theorem video 2 for once we get a little better at it.
We need to, because I need to practice a lot.
Yes.
That doesn't even look like
Okay.
nothing. I never did that.
You did too.
I don't think so.
Okay, Mom. So let's just practice a couple simple problems, and we'll just round to the nearest tenth,
Okay.
and we'll do other...
And you always draw it like that?
I mean, you could draw it like this. Just as long as you
always
have...
put that little box in it, though?
That tells us that it's a right angle.
Oh,
so
okay.
usually these problems will have that somewhere.
Okay.
Okay, so we're just going to be practicing finding what the length of the hypotenuse is today.
It is a hypotenuse.
And then other days we'll find out legs, missing legs.
Okay.
Okay, so let's pretend this is 8. And let's pretend this is 4.
Okay.
And we want to find out what that is. So do you remember we take this number?
And we make it like 4 times 4.
Which is?
16.
Okay, so we have 16. And then what do we do with that?
64.
Good.
8 times 8 is 64.
And then we add them together.
Okay. So 6, 7, 8, 9, 10. So put the 0 and carry the 1. And make that an 8.
Okay. So then this one times itself would be 80.
So we know like 2 times 40 is 80.
But we don't want to do 2.
Oh, it's got to be like...
It's got to be what number times itself is 80. So like, let's think of our number. We're going to guess what it's in between. Okay, so like...
8 times 8 is 64. 9 times 9 is 81.
And this is 80. So it's so close to 9. It's just a little bit less.
So we have to do it less. Can't
So-
be 9. It has to be 8 by 8.
Or
8 times 8.
Or 8.9 times 8.9.
Yeah.
Okay, so what you can do is you can take this 80, put it in your calculator, and square root it. And what did we get?
8.9.
Yeah, and the number goes on and on forever. We're just rounding to the nearest tenth. So this length would have to be about approximately 8.9.
Oh.
Does that make sense?
Sort of, yeah.
Okay, I'm going to give you
Yeah.
1 for you to do all on your own.
Oh, okay.
Okay.
I don't like it that way.
Well, we have to show that it doesn't always look like
Okay.
that. Okay, so let's pretend this is 6, and let's pretend this is 7. Okay, and you're going to find that.
Okay, so 6 times 6 is 36.
Yeah.
So we do 36.
Mm-hmm.
7 times 7 is 49. So
Yep.
we do 49.
Mm-hmm.
So we do 9. That's how I add. 1, 8.
Perfect.
So we go 85 here.
Yes, but is 85 the length of that side?
No, it's the square root of it.
Okay. So we have to think of something times itself that's 85.
Is that the square root thing?
Yeah.
Okay.
So remember we said last time this number is kind of close to the last one we
Yeah.
did. Like 9
So
times
9 times 9 is 81.
Yeah. So is this
So-
going to be bigger or smaller than 9?
It's going to be big. It's 9 times 9. It's going to be bigger.
Okay. So then we're going to type in 85, square root it, and look, we get 9.2.
Oh, so we're going to go, this is like approximately 9.2.
Yes.
That's it?
Yeah.
Oh, okay.
So they use this a lot in construction. Construction workers, they always know the Pythagorean Theorem.
Oh my God. I
Yeah.
have no idea.
So we'll get into a different lesson where we're missing one of these sides. So we'll have to subtract.
Oh my gosh.
No, you can do it. I
Okay.
want to write one more thing down. It's the formula. The formula for Pythagorean theorem is a squared plus b squared equals c squared, and c squared always has to be the hypotenuse.
Where's a?
It's either this or this. It doesn't matter.
A plus b
This squared plus this squared
equals
that squared.
that.
Or this squared plus this squared is that squared. You can,
Okay.
Either one of these can be a or b.
So
These
you
are
just have to remember that that's the,
hypotenuse.
oh, that word. Hypotenuse.
Hypotenuse. You can do it.
Hypotenuse.
Mom, you did it. You know Pythagorean theorem.
I never heard of Pythagorean. Pythag.
That's right.
Okay, got it.
Good job, Mom.
Thanks.